Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag again. My initial plan was to go to definitions since I did the last video of flotation. But I'm just taking a small detour. I thought I will finish one more topic called density, which is one of the beginning chapters of your stability under C versions or second mid versions also. So I'm going to talk about density first today. And once I finish this concept, I'm sure this time I'll not to break the promise. I can go back to my definitions. So let's start off density. Just share the screen. Okay. This is one of the first topics, as I said, when you look into your stability chapters, which will be for your pre-C level also. I'm going to give you a quick word of caution before you start doing any calculations on your calculator. Try to keep your mode setting. This mode setting has got three options available. One is degrees, then it is gradient and radian. Make sure your mode is set on delta. In this module, what I will do is we'll talk about density and various shapes, which do come in the questions. And most of the calculation, what we do in stability involves volume. And you will come across two types of questions can be given to you in your volume. So we'll look into that also. Let us start off with what is a simple explanation of density. I've given you two pictures. It is very evident in this picture if you see. The left side picture is showing you some molecules which are given in a particular pattern, and the right side picture shows you in a kind of a pattern which is not very even and more loosely arranged. So if you ask me in very, very simple terms, I will not go very technical. The meaning of density can be explained by using the closeness. So I say the closeness of molecules of a substance can also directly tell you what is density. Again, two more pictures I've shown you. These pictures, you'll see the left-hand side of this green picture also. The molecules are placed very closely. And you can see the right side, the green picture is showing you the molecules placed a little bit apart. And same way is the blue color and the red color. So I can very easily explain a density in a very simple terms based on the closeness of molecules. The more the closer they are, you can also call it more denser they are. And more loosely packed they are, so I can call it less denser also. So how can you measure it? I can measure it by a simple experiment shown here. I will take two jars or two containers of equal volume, and I'll fill up two different liquids, let us say up to full, the full jars, both of them. And you can see this molecules are placed differently. So it's very evident the volume of the two substances are exactly same. Why? Because the jars are exactly the same. Now, what is different here? The closeness of molecules or the number of molecules, whatever you want to call it. It will be very evident that tightly packed molecules will weigh more than the loosely packed. There's a simple way of understanding what is density. I'm not going into technical features. I'm just telling you a very, very simple way. So how can you measure it or represent it? Sorry. The definition can be given as a simple mass per unit volume. So the volume was constant in those two jars which we saw. The mass was different in both the jars. I told you one will weigh more than the other. So this is a simple definition of density, which is mass per unit volume. So I can call it mass divided by volume. For our stability purpose, even though in the physics the definitions are slightly different, for stability purpose, we will always take mass equal to weight. But in physics, for a weight, force of gravity is involved. We will not talk about it. The commonly used units of density is tons per meter cube. That is what we use in the present day shipping or navigation or stability, whatever you want to call it. A few other units are also there through which this tons per meter cube got evolved. And I can call it grams per cc, it can be grams per milliliter, or it can be kg per liter also. Now, the same density is equal to mass by volume can be looked upon in a slightly different way. I can say the density is directly proportional to the mass. That means more mass, more density. Inversely proportional to the volume. So that means if the volume is more, your density will be less. I can rephrase the same formula. D is equal to m by v and is same as mass is equal to volume into density also. We used this formula earlier in the previous flotation exercise as well. You will come across in stability one more title called as a relative density. So we'll be using this very, very commonly. Questions will be coming based on relative density. So what is relative density? It's nothing but a simple ratio of any substance density to that of fresh water. And fresh water's density is 1 ton per meter cube. So if you divide any density with fresh water, the denominator is 1, and you will see the units will get cancelled. So I've given an example. Let us say seawater's density is 1.025 ton per meter cube. So I can call it RD as 1.025. So all I've done is I've removed the units. The units have been removed. So I can simply call as 1.025. Now, just as the last slide, we said that you can have mass and weight, where weight involves force of gravity. Similarly, you will see that one more way of representation of density or relative density is your specific gravity. Again, here, specific gravity involves force of gravity, but the answers are still the same. You will get a value without any units. So for me, in stability purpose, please don't bother here. RD is equal to HG, where both of them will not have any units, so we'll go with that. Now, in your basic chapters, the most common type of questions comes with different shapes. So I'm going to take you through different shapes. And my final ultimate aim is to calculate the volume and then the mass. So I'm going to look at different shapes. Let me go through different shapes. Start with one of the most easiest one to understand. It can be called box shape or rectangular shapes. You can see this is an empty tank. Let us say it has got a length, a breadth, and a height. This shaded area, what I marked, I call it base area. This base area is very critical for you to calculate all your volume calculations. So what does it mean? Let us see. Now, if I ask you to calculate the volume of this tank can be empty or it can be fully occupied. The volume will be same. So let us look at the empty tank or fully loaded tank. What is the volume calculation? Please look at this formula. Before I start anything, I need to know what is the base area. It is shaded here. You can see that base area can be calculated by length into the breadth. But then what is volume? Nothing but length into breadth into the height. which is also called as volume is equal to base area into height also. And this is valid for an empty tank or a full tank. But we are not always empty and not always full. Let us say we start filling cargo. So what happens if you fill cargo? If you start filling any liquid cargo, first base area is going to be completely covered, and then after that it doesn't have any space, so it starts rising up vertically. So let us say it rose up vertically up to this red color level. The cargo rose up to this level. So there you will come across two features now. Vertical height from the base is called sounding in your shipping industry. And there is an empty space which is left out. And that vertical height is called an ullage. See, in all your tanker calculations, you'll be dealing with ullage, not the sounding. All those candidates who are not tanker, I'm sure you're already familiar with the sounding, but you may not be familiar with the ullage in case you have not calculated. Let me just briefly tell you that in tankers, any measurement with a tape or any fixed instrument, we always calculate ullage and then convert into the sounding and then do the volume calculation. So for you, ullage is very important to understand the concept, how it is given. So this was a simple explanation of what is ullage. Ullage is that empty space, vertical height of the empty space. Now, let me ask you how to calculate the quantity of the cargo. We have already seen the empty tank. Now I'm going to look at the quantity of the cargo. I told you when I start filling, the liquid will first fill the base area. That means the base area is same. That is what is L into B. Now it has gone up to a height which is called sounding. But in tanker questions, always will deal with ullage first. So you need to understand what is an ullage. For this particular tank, the total height of the tank is H, capital H. So that means the capital H involves sounding plus ullage. So in this formula, you will know what is the height of the tank. You will be given the ullage, so you can find the sounding. For me, ullage directly does not give me the volume of the cargo. So that means I need to find the ullage from the ullage, I need to find the sounding. So what I do is sounding is equal to capital H minus ullage. Now, the moment I get the sounding, now I can calculate the volume of the cargo inside the tank. Volume of the cargo is the base area, which is the same, and the sounding. So this is a simple way of looking into a rectangular tank. Now you should realize that rectangular tanks need not be exactly like this. The questions can come with a small modification, and in your real life also you will have that small modification. Let us see what is that small modification. I've left the previous diagram untouched. I'm going to introduce something called your ullage pipe, or if you call it as a sounding pipe in your ballast tanks. But in your cargo tanks, it is called your ullage pipe. This height will be given to you. You will know in the question. In real life also you will know. Now in the same condition of the last slide, you can see up to the red level I have marked the cargo. You have an instrument. So let us say I have an instrument like this where a tape goes down and there's a float. It goes and touches the liquid. So this reading, what you take exactly from the top of the ullage pipe, is also called as a reported ullage. You should realize this reported ullage involves two things. It involves the height of the ullage pipe plus your actual ullage. So that is why I've written reported ullage is equal to height of ullage pipe plus your actual ullage. End of the day, I'm interested in sounding. So you can see sounding, I have clearly written the capital H of the tank minus your actual ullage. The height of the ullage pipe is not required for you to do any volume calculation. It is just a small pipe through which a tape can go and measure any liquid. So this is not involving any volume, so I have to remove it. end of the day, I'm looking at actual ullage. So I've written sounding as H minus actual ullage, just like the previous. And again, once I get this, I can find the volume of the cargo. So please remember, reported ullage is height of ullage pipe plus actual ullage. I'm not interested in height of ullage pipe. That is why I remove it. I calculate actual ullage. And from actual ullage, I'll find the sounding. So this is how you go about in your rectangular calculations, rectangular tank calculations, or any other calculations also. Before I go to a different shape, which is a triangular cross-section shape, questions can come in triangular cross-sections also. Let us quickly have a look at a few formulas. I'm not going to spend much time, but let me just quickly give you many candidates forget this, even though it has been taught to you in schools. So you can call one kind of triangle as a right angle triangle. You will have hypotenuse, opposite, and adjacent. So this is what I'm showing you. I'll be quick on this. I will not spend too much time. And these three sides and the angles can give rise to a couple of formulas, or your thetas, or sine theta, cos theta, and tan theta, trigonometric equations. Similarly, I can use something called Pythagoras theorem to solve the sides. All this will be useful for your problem calculations. Let me show you the same right angle triangle again with a different naming. Why? Because these names will be used in all your problems. You will see that the top tip is called your apex. The bottom horizontal line is called the base. And this vertical distance between the base and the apex is also called as height. I'm going to show you an isosceles triangle very similar to this. So here is the base, that is the apex, and this is what is called height. Using these triangles, I have to calculate the area of these triangles many times in the question. So I'm giving you a small block which tells you about area. You can see area of this triangle is half base into the height, which is shown in this diagram here. And what is height? Height is the perpendicular distance from base to apex. So this was only a recap of your simple maths or trigonometry. Let us continue, because I can give you shapes like this also. So when I give you triangular shapes, three conditions are possible. The first condition is I have the axis of this your triangular cross-section tank. Axis is horizontal to the water line, and at the same time apex is upwards. This is what I mentioned. The length is horizontal to the water line, and your apex is upwards. And you can have water at any level. So I've just given you water at the top level of the apex also. Now please look at the right side picture. Here also, the triangular tank length is horizontal to the water line, but this time apex is downwards. So that means I can have water up this. So these are the two possibilities, but there's a third possibility. I can have this same tank kept in vertical direction also. So you should agree that if I start filling this tank from the top, the first place the liquid will fill, you will see, is this place. So that is why I call this base area. But this time the base area is a triangular cross section. Again, a tank can be empty, tank can be full, or it can be partially filled. So let me look at the tank empty or tank full condition. Please see this. The base area is half base into height. So the volume of this empty tank is area of the triangle into the length. I've just marked this vertical as L because I'm going to involve something called H. And this H, I'm talking only about your triangular cross section. I didn't want to create confusion, so I marked it as L. Let me fill up a cargo. Again, obviously, the first base area will fill up, then it will vertically rise. So I will have a sounding and an ullage. So if I want to look at liquid cargo, This area is still the same, and volume of that cargo is base area into the sounding. There are a few formulas again I've written. What happens in case the triangular cross section is not exactly isosceles? It can be. So I've given you three formulas which you can use. The first one is the most easiest one, breaking them into a right angle triangle. So I can use it. You can use any of the formula. You can use equilateral triangle formula or a generic formula also. So these three formulas you can use. Let's go into a next shape called cylinder. So you can see that I've shown you two cylinders. One axis is horizontal to the water, the other one axis is vertical to the water. If your axis is horizontal, I will call this as a length, and if axis is vertical, I can call this as a height also. So these are the two possibilities. Now let me take a tank which is vertical. Again, same thing, I can calculate the empty volume. The base area is a circular base area, so area is pi r square. You see, volume is your area into the length or the height. But what happens if I fill some cargo? You will see it will form this kind of shape. That means again I have a sounding and an ullage, but I need sounding for calculation of the volume. So I've shown you volume is base area into the sounding, which is pi r square into the sounding. So it's very simple calculating cylindrical shapes also. Let me go to the next shape where questions come with a topic called trunkway. For you to understand trunkway, you can see I've shown you the old rectangular tank, and on top of the tank you can see one more structure which is again rectangular but a smaller structure, and this concept is called trunkway. This concept can come with an additional ullage pipe also. If anyone from bulk carrier sailing, you can understand on top of your normal tank, you have a hatch and you have a coaming and a hatch cover. So that also forms a big rectangle. So you can use that to visualize this kind of trunkway. So I have an additional trunkway below the main tank. So I'm above the main tank. So how do we go about these questions? Number one, I've shown you this is the main tank and this is your trunkway. You can have two questions. Number one, the liquid is filled only in the main tank. Number two, it can fill up the main tank and come into the trunkway. So let us quickly see what are the formulas you can use. As usual, my empty main tank is going to be L into B, which is your area of bottom cross section. So volume of the empty bottom tank is area into the height. Now let us look at the trunkway. Please remember the same length and breadth I marked with a smaller letter. It is not capitals, L into B and a small h. So you should agree volume of the empty trunkway is also L into B into H. Okay. Now let me give you two conditions. First, my cargo was partially filled only in the main tank. So how do I go about this question? Do you agree that this is the sounding? And very evidently this is the ullage of your main tank. If I use any tape to measure, you will see I would have given you this as the reported ullage. For me, in this reported ullage, right now the ullage pipe and the trunkway are of no use. That means my aim is to find what is the ullage, actual ullage of the tank, and then I'll go with the sounding. Okay. So for me, let me say this is volume 1. Volume 1 is base area L into P and the sounding. It's very simple. So let me give you a second case. The second case tells that the main tank is completely full and the liquid has gone partially on the trunkway. So I'm showing you here also. So then what do I do? I can separately calculate the volume of the main tank, and then I can separately calculate how much volume has come into the trunkway. So main tank is very, very simple, length into breadth into height, no problem at all. Now let us look at this feature. So you will have a small sounding here, you will have a small ullage here also. And right now, if somebody had taken measurement from the ullage pipe, you will see this will be the reported ullage. So now you can see I have volume 2 also. This volume 2 is a small l, small b, and the small red color arrow, which is talking about the sounding only in the trunk. Now, if somebody asks me what is the total volume, you'll have to add volume 1 plus volume 2. So this is the concept of using trunkway. Questions can come partially filled in the main tank only, and questions can come when the liquid has come up to the trunkway, where is again partially filled. Let us look at one last concept, which I told you. Two type of volume calculations are used in all our problems. So what are the two types of volume calculations that are used? Simple way of explaining is a rectangular tank again. Again, I have given you L into B into H. All of you should agree. If I ask you what is the volume of the empty tank, it is L into B into H, which is never going to change. Similarly, if I fill up the tank cargo with complete cargo also, the volume of the cargo is also exactly same. So let us consider this maroon color vector as volume of the tank. That means it can be empty or full. Okay. Now I'm going to partially fill the cargo. Let us say up to this level. If I partially fill the cargo, you can see I will get a sounding, and you can see I will get a knowledge. And let me call the volume of the cargo as omega. So you can call this only cargo as omega. And if I give you a condition, the tank is full, that means capital V is equal to omega. So that means 100% full. But if not, then do you agree that I will have an ullage space on the top and I will have a cargo space on the bottom also. So this is what is your total tank configuration. Can I write like this? Yes. That means total V, that is the capital V of the tank, is always equal to cargo volume plus ullage space. That is what I've just shown you. Now, the first type of volume calculation comes. He asks you, please find the volume of the cargo if 2% of the tank is to be left as empty, which is ullage space. 2% of the tank. So you should realize capital V is never going to change. That means I have a cargo volume, which is omega, and the empty space is 2% of the tank. Tank is capital V. So this is what is the equation you will form. I'll remodify this equation. If 2% of the total tank is empty, so do you agree 98% of the tank will be full of cargo? So omega is equal to 98% of the tank. In other words, you can write it like this also, 0.98 plus 0.02V. All I have done is I've divided by 100, nothing else. Let us look at the second concept. Now some question asks you that the ullage space what you leave, percentage of the cargo loaded. Please remember it is not 2% of the tank, it is 2% of the cargo loaded. Then the equation gets modified. The main base equation is still the same. Capital V is equal to cargo volume plus ullage space. Please look at the change now. Capital V is equal to cargo volume, which is omega. But instead of 2% of capital V, I have to write as 2% of omega. Let us sort this out. Omega can be called as 1 omega also, and 2% can be called as 0.02. So if I finish this equation, capital V is 1.02 omega. My job is to find how much is the cargo volume. So all I can say is omega is equal to capital V by 1.02. So this will give you the cargo calculation. Please Two types of calculations always come in the question. Please be careful. What is he asking you? Is he asking you ullage space as 2% of a tank or 2% of the cargo? So this brings us to the end of this basic density calculation, shapes, and the volume calculation. I hope it was useful for you. And as I promised, I'll surely start the next module, whichever whenever I'm giving you. There'll be continuation of the definition what we saw earlier. If you remember, we had finished definition up to water plane coefficient. So from that, till then, keep watching Del Prayag and welcome. Namaste.